investigated about this like 2 years ago. It was more on the economic or econometric aspect of this matter, about the time series encountered by macroeconomics, and later on in literature number 2, financial or micro level observations. And then in the recent paper, literature number 3, which is the one I'm going to talk about mainly today, is kind of a mixed sort of finance-related things and also methodological study. So this paper is currently under revision with the Royal Statistics Society, and hopefully it can be published in several months. A bit of background. So what we are doing here, in the traditional sort of statistics, you draw from the same distribution, yeah? So you have first observation, you draw from the same distribution. Second one, you draw from the same distribution. You know, Randolph talked about perhaps like draw from the same distribution, analyze that. Then in time series, the problem that occurs if you have a different distribution. Right? So these are the sort of simulated example of how things work usually. You maybe have the same distribution for a pair of time and they change it. In engineering, they call it change point. Economics, they call it sort of time varying distribution, things like that. Now you have this kind of situation that the classical solution is that you have several estimation methods, choose different sort of windows, and try to tackle it that way. As a more sort of financial and empirical sort of aspect of it, we can actually grab a very near-term example in 2020, as we had a sort of COVID problem, global pandemic. The market crashed, and different variables in the financial market reacted differently. So somehow you can see that this sort of, so on the left and right, these are very special financial contracts called yield and VIX, and they have special sort of time varying distribution and relativity compared to the financial industry. So these are very interesting and motivating empirical examples, and these were studied closely in literature number 3. So the idea is that you have this distortion and distribution is different. How can we estimate and evaluate forecast? A bit of sort of algorithmic approach rather than giving out all the rigorous mathematical definition. So the key ingredients I'm working around is this. I'm using this, but are these 4 terms essentially. So you want to specify how would you like to do your learning by using loss function and a set of learning adaptation. And then you have the next 2 terms, which are kind of traditional statistical methods, and you proceed with a traditional estimation and a forecast, and then you feed everything into this adaptive learning regime, which either, presently it can do the model selection or ensembling, that then outputs the forecast. This is sort of a regime in a very simple explanation, I guess, graphical explanation. This is just to demonstrate that you can engage with a lot of contemporary machine learning techniques. You can use very simple P1 as loss function. There's some trick around it, and this trick is very useful. That you can draw from different forecasts, and that's very fun. And then previously I played around optimization, which works pretty well as well in time series context. These are the sort of key methodology. Let's quickly look at the sort of empirical result. So the empirical result shows that if we pick a fixed model, even if we sort of optimize it beforehand, so you optimize the fixed model, and then we go ahead into next quarter, it cannot perform very well, especially during the pandemic. So the market crashed, the market kind of misleading, or was kind of misleading, and if you use the same distribution, it cannot give you a very good prediction. Whereas the adaptive learning method, you can adapt as it's named, as it's adapted, it adapts to these sort of underlying changes, and it can perform much better. The good thing about it is also it's easier for interpretation and access to model. As we can see on the panel, we can have direct access into model formulation, which is very helpful, but all sorts of application into interpretation. And again, because of the access, we have direct access into parameters and models. We can do parametric testing, and we can do model testing, Bayesian frequencies as we wish. I have 1 minute left, so just gonna have a quick remark on some statistical observation in financial data set. So this is a relation matrix between statistical evaluation and financial evaluation. So we can see that actually, in general, the MSc doesn't do a good explanation on how good the model is, especially in the 2020 when we had a big structural change in the market. This is another sort of illustration to show that MSc performs very poorly. Whereas if you look at other financial evaluation matrix, be a better explanation or evaluation to our models. I think I run out of time, and thank you very much. I'll be around post session, and I'll have to check out my website for more information.
I think Parley has a poster. We can have one question maybe from